Here's a brief overview of what's termed the scientific method, an experimental approach to collection of data. Let's outline the scientific method. So the scientific method is a process for experimentation that's often used to explore observations and ultimately confirm or not a proposed hypothesis or to answer stated research questions. Some areas of science can be more readily tested than others. For example, scientists studying how stars change as they age or dinosaurs digested their food cannot fast forward to a star's life by 1,000,000 years or run medical examinations on feeding dinosaurs to test their hypotheses. When direct experimentation is not possible, scientists modify the scientific method to suit. In essence, there are probably as many versions of the scientific method as there are scientists. So the first thing to note about the scientific method that is often stated in generic form and can be adapted to suit an individual approach to undertaking a specific type of research. However, even when the approach is modified, the generic process of the scientific method remains the same. This process includes to discover cause and effect relationships by initially posing a hypothesis or stating research questions that need to be answered, by carefully gathering and examining and analysing the evidence collected, and assessing if all the available information and data gathered can produce a logical and justifiable answer to the initially proposed hypothesis or questions. It should be noted that even though the scientific method is shown as a series of steps in a diagram overleaf, uncovering new data or new thinking can cause scientists and engineers to repeat steps of the process at any time. This is sometimes termed an iterative process. The scientific method can be applied to physical experiments, to design work, development of new manufacturing processes, and to non-physical research, such as determining people's feelings about a particular situation or occurrence. The process is simplified as a flow diagram showing the steps that are commonly undertaken, but as suggested above, this flow diagram and the steps contained therein may vary between different researchers, institutions, companies, but the overall generic process will be similar. So here's a flowchart of the scientific method. Commences with a question or a problem to be solved. We undertake background research, develop a hypothesis. We then test the hypothesis with an experiment, consider the initial results from the experiment, consider if the experiment is working. If not, we then reconsider our procedure, check all the steps and the setup used, modify as required, and again test our hypothesis. If the experimental procedure is working, we analyse our data and draw conclusions. If the results or the conclusions do not completely align with our hypothesis, again we form an iterative process where the current experimental data becomes our background research for a new or a future project, and then we generate a new research question, hypothesis, and we will start our research process again from a new hypothesis. If when we analyse our data and draw our conclusions, the results do align with our hypothesis or answer our research questions, we communicate the results or the findings. And of course, we may want to communicate our results and findings at the stage where our results or conclusions do not confirm our hypothesis or answer our research questions. So that's the generic overview of the scientific method. If you undertake your own research, you'll find many other versions of this particular process, but they'll have very, very similar characteristics, very similar steps in the process. I've just included this flowchart for interest. This actually relates to something called the engineering method. Generically, it's quite similar to the scientific method, but here we're initially defining a problem to be solved, we're undertaking research, we define requirements and develop a specification, sometimes termed a design specification, we generate concept and select an optimum solution, we develop the concept and prototype the solution, then we can test our solution. If the solution doesn't meet our requirements, then we again iterate the process at various stages here. If the solution does meet the requirements, then we communicate our results and our findings. And of course, we may also want to communicate our partial results to our audience, even if they do not solve the initial problem. So that's termed the engineering method. Again, generic steps there for your reference. And here's something called the design cycle, which again is quite similar in the generic steps of our engineering method. And you can now go away and research many more different types of flowchart problem-solving processes to solve scientific, engineering or design-based problems. Here's the bibliography, a list of websites used to help generate this presentation. I hope you're now in a position where you can undertake your own research and develop your own understandings of the scientific method. Thank you for viewing.